Okay, so 1A, number 3, practice. So the first two questions, we have to graph them. So what I will do is actually look back at my notes, and looking at our notes, any number that's added after the parent function is ended, so that parent function absolute value is ended here, that means it's up 3. So we're going to take the parent function and move it up 3. Looking at the inside, this is opposite of what you would think. So minus 2 means we're going to go take the parent function and transform it, translate it, shift it right 2. So now we're going to look at the parent function. Each one of these points go by, or intervals go by 1. So we're going to, my parent function is 1, 1, negative 1, 1, 0, 0. This is absolute value, so it's v. It's good to practice that over and over again. We're going to go right 2 and up 3 for each point. So I'm going to start with the little bottom of the v, kind of, we can think of it as the vertex. Right 1, 2, and up 3. 1, 2, 3. Each point we're going to go right 2, 1, 2, and up 1, 2, 3. And the 1, 1 will move that right 2 and up 1, 2, 3. And we'll draw the graph. And there is our final answer. You could double check this on Desmos. That will definitely work. Next, we have, let's see here on the outside here, looking back at your notes from today, you have, that's a reflection across the x-axis. And on the inside, that means we're going right 1. And this is a cube root function. So a cube root function, we're going to draw the quick parent function looking back at our notes from day 1. Those are the 3 key coordinates. Cube root function curves off to the right pretty quick and curves off to the left pretty quick. And now we need to take these points and reflect them. So each point we're going to reflect across the x-axis. So it's thinking about the x-axis as like where we're folding this coordinate plane on. Any point that's above the x-axis, we look at how far above it is. Like 1, 1 here is 1 above, so we're going to go 1 below. 0, 0 is going to stay there because it's right on the x-axis, so distance-wise from the x-axis is 0. And we're going to go 1 below, so that's really 1 above. And do a quick little off to the right, off to the left. Now, so that's reflected. Always do reflection first. Now we're going to go right 1. Each one of these blue points, we're going to move right 1, and we're done. So right 1, right 1, right 1. Redraw it. As long as you have somewhat of a good shape, that's good. So green is the answer. If you want to make sure I know exactly what the answer is, you can either circle it or just draw a little thin line saying, hey, this is the answer. All right, moving on. We have 1A, number 3. Write the equation now from the graph. So cubic function, I see that number 2 here is there's another number 2. That's a cubic function. So I'm thinking from your notes, you have this graph. Now that graph doesn't look exactly like the graph that you see here. The middle point here is right where the graph, the slope almost goes straight, like horizontal. So the slope is very horizontal here. Where the graph changes slope is where that middle point is 0, 0. So that's the point that I'm going to follow. You see the orientation from left to right is the same, so it does not get reflected. But if we follow that middle point, it goes right 1, 2, 3, and up 1. So now we need to put those right 3 and up 1 into the equation. So our general equation is y equals x cubed. To go up 1 or right 3, we'll go right 3 first. We're going to put it with the x. I'm going to put it in parentheses. And right 3 is minus 3. And then we need to go up 1, so plus 1. And there's our equation. X minus 3 cubed plus 1. All right. Next problem, we see we have a square root function. It's the only, there should be an arrow off to the left here. That's my bad. So a square root function. From the parent function, starts at 0, 0, and goes off to the right. 0, 0, that's the starting point. I'm going to look for where the starting point is. It's right here at -1, -3. So if the first thing you look at is the orientation of the square root function. The way it's shaped is different. This goes off to the top right, this goes off bottom right. So that means it's reflected. So there's a reflection. And then once it gets reflected, it would look like this. And then from 0, 0, it's going to go down 1, 2, 3, and right, left 1. So now we need to put reflection, down, 3, left 1. And to show each one of these, we have reflection. That's right after the equal sign is a negative. This is a square root function, so square root symbol. Left 1 will be x plus 1 inside. You can put it in parentheses if you like to show that x plus 1 is all underneath the square root. And then down 3 is on the outside, subtract 3. Moving on, rational functions. So for these, so this is rational. So the equation is y equals 1 over x. The parent function goes through 1, 1, looks something like that. Goes through -1, -1, looks something like that. Now this is the trickiest part of rational function, is to pick the point that those key coordinates that I had you guys remember from first day. Pick where those are on the graph. Well, this top right graph looks like it's the key coordinate that I chose is right in the middle of the curve, or pretty close to the middle of the curve. So each one of these points, so looks like that one went right 1, and that one went right 1. So it looks like we just go right 1. Both points went right 1. So on the rational function, it's 1 over x, and right 1 is, oh, not plus, Mr. J. Minus. Opposite of what you would think. All right, number 5. So we have a quadratic. So it's y equals x squared. Looks like we have a reflection upside down. And the vertex is what I typically look at for the key coordinate. And the vertex, when it got flipped upside down, look, well, that's pretty ugly, but I'm still looking at the vertex here. That just gets moved left 1. So in the equation, we have x squared, and with the x, left 1 would be plus 1 squared. And you're like, hey, Mr. J, you totally forgot the reflection. Yeah, the reflection right after the equal sign is a subtraction, and that will be the graph there. All right, next we have exponential. Exponential parent function typically goes through 0, 1. And remember, e, you can have e if you want. If you don't want e, you can have a number like 2. So we could have y equals 2 to the x. That's fine. E is a number. And to find where that key, that's terrible, where that key coordinate 0, 1 is on your new graph, you follow the new graph until you find a nice coordinate. And I guess the nice coordinate would probably be, again, right in the middle of the curve, right down here at 0, -3. So now we have from the coordinate here at 0, 1 to 0, -3. What's happening? 1, 2, 3, down 4. The orientation of the graph from left to right, it looks the same. It's not upside down or anything. So we are going down 4. So this is the equation y equals e to the x. After the parent function, e to the x, that's the parent function. We're going to say down 4. So to go to do that, it's just -4. So there's your equation. And lastly, we have, what kind of graph is that? That is, looks to be cube root. So it looks like this. Cube root function. Cube root function, but you look at the orientation, it's not the same. It starts bottom left, goes to the top right. This one starts top left and goes bottom right. So the orientation's wrong, so this is cube root. It must be a reflection. And I really would, you look at this key coordinate here, cube root is right where the graph almost goes straight vertical. That is the key coordinate 0, 0. We gotta look, don't always pay attention if we on paper have a point written down. Remember, a graph is an infinite amount of points put together. Try not to have a point, but this one does, number 7. So it's not always, that's not always the key coordinate, so don't key in on that. Look where this graph goes really vertical, where the graph or the slope changes. So we're gonna go down 1, 2, 3. So we got a reflection and down, down 3. So it's a cube root function. Is there any kind of left or right? Nope, so nothing inside, underneath the cube root. And then down 3 after the cube root, after the parent function. You're right, so the top of the, make sure the -3 is not underneath the top of the cube root.